It's day 41 of communication practice with ChatGPT. Today I don't have much time because I occupied by many tasks. So let's see if I can finish this quickly. Hey ChatGPT,
Ok, mình nghe đây. Có gì
can,
cần mình hỗ trợ không?
can you speak in English?
Sure, I can switch to English. What do
Okay.
you need help with?
Uh, Today I just want to have a quick communication practice with you since I have a SQL interview this afternoon and I have to really do the rehearsal for it. And anyhow, just 5 minutes is good. Now let's catch up.
Absolutely, let's do it. We can run through a few quick questions. How about we start with a common SQL scenario and you can practice your response?
Yeah, that sounds lovely. And please do the query based. I mean, there will be 2 or 3 problems that need to be solved in the interview, and I want to practice that. So please help me with that.
Got it. Let's say you have a table called employees with columns employee ID, name, department, and salary. Here's a quick scenario. Write a query to find the average salary for each department and only include departments with more than 5 employees. Give that a try and then we can go over it.
This quite good question. Let me think about it for a little bit.
Take your time. Once you're ready, you can walk me through your thought process or share your answer, and I'll give you feedback.
Okay, I can share with you my thought process. First, I would want to get the department that have more than 5 employees, and with that, I can do a CTE with the group by on that. Um, I don't remember correctly exactly the table name. Let's say it's employees, and I would do a CTE like a department with more than 5 employees as select department from employees grouped by count distinct employees ID. Uh, I'm sorry,
That's a
group by the department ID having um, count employee ID more than 5. So by that, I have a city with the department ID, and so second is just do the average. So I would do select um, select average uh, average department average, I mean salary from employee where department uh, in select um, department ID, where department ID in select department ID from the from this department with more than 5 employees. So that one way to solve it.
great job. Your approach is clear. Using a CTE to filter departments with more than 5 employees is perfect. One small tweak in the main query, you'll want to group by department to get the average salary per department. So, the final query might look like this. With depth with count as, select department from employees, group by department, having count employee ID over 5. Select average salary from employees, where department in, select department from depth with count, group by department. This way, you're making sure to return the average salary for each qualifying department. Good job thinking it through.
Can you show me the solution again for the main part?
Of course, here it is again. With depth with count as, select department from employees, Group by department, having count employee ID over 5. Select average salary from employees, where department in, select department from depth with count, group by department. This way, you're making sure to return the average salary for each qualifying department. Good job thinking it through. Then
Okay.
it calculates the average.
Okay.
No
I
problem.
got it. Let's let's have another question.
Sure thing. Here's another scenario. Suppose you have a table orders with columns order ID, customer ID, order date, and order amount. Write a query to find the top 3 customers with the highest total order amount in the last month. Give that a shot and we can go over your approach.
Okay. Um. So there are two ways to deal with this. Um. We can either uh use order, or we can either use row number. So
Exact.
essentially, I, for example, I would first we would want uh, to get the the timetable which have the amount of each customer last month, total amount of each customer last month. So I will create a CTE like last month spent as select customer ID, and some amount from order, uh, where the date between last month first and last last day of the last month, between that, group by the customer ID. By that we will have the um, the total amount spent by each customer last month, and then we're gonna select on that. So two way: select customer ID um, from last month spent, order by amount, descending, limit 3. That's a one way to get 3 most customers spent. Second, we could do the like, for example, we can apply window function. Like, let's say we want to dance rank, so I would say select um, customer ID, dance rank over partition by customer ID, uh, order by um, amount descending, and from the last month spent, uh, and that will be another city, let's say it uh, ranking spent last month. And then we're gonna select customer ID from ranking spent last month, where the rank dance uh, smaller or equal than 3 to get the answer. So that my answer.
Excellent explanation. Both methods work well. Using order by over comma limit 3 is straightforward and efficient, especially if your dataset isn't huge. Using dense rank is great if you want a more flexible and readable approach, especially if you need to handle ties or get more insights. Great job thinking through both solutions.
Okay. Um, Let me think about it. Order by uh, and dance rank. Okay. Can you tell me? Finally, can you tell me the difference um, um, between order by, between two solutions in a big data environment? Like, how is difference between order by and um, having dance rank together result, order by limit, and having the dance rank to get the result.
In a big data environment, the difference comes down to performance and scalability. Using order by over comma limit 3 is straightforward and can be faster for smaller datasets because it simply sorts the data and picks the top n rows. However, as the data size grows, sorting becomes more expensive, and order by might require a lot of memory and processing power to execute. On the other hand, using dense rank with a window function can be more efficient in a distributed processing environment like Spark or a massively parallel processing MPP database. Dense rank assigns ranks within partitions, which can be parallelized and doesn't require a full global sort. It can also handle ties more gracefully. After assigning ranks, you can filter the top 3 ranks, which might be more efficient for very large datasets and can reduce the amount of data shuffled across the cluster. So order by over comma limit is simpler and often faster for smaller or moderately sized datasets, but dense rank with a window function is often more scalable and efficient in big data environments.
Okay, I'm not still quite understand it yet. So can you tell me, um, explain to me more simply?
Of course. Simply put, order by over comma limit sorts all the data and then picks the top 3. This can be slow if you have a huge amount of data because sorting everything takes a lot of time and resources. On the other hand, dense rank assigns a rank to each customer based on their spending. It's like labeling each customer with a number, 1, 2, 3, etc., based on how much they spent. Then you just pick the customers labeled 1, 2, and 3. This method can be faster in large-scale systems because it can process the data in chunks rather than sorting everything at once. In short, order by over comma limit is straightforward but can be slower on huge datasets, while dense rank can handle large datasets more efficiently by ranking customers without sorting everything.
Why we why can we rank all the customer without ordering everything? Because I thought you have to know the order of it in terms of every other order to know where it is.
That's a great point. When we use dense rank, it still orders the data within each partition based on the specified column. The difference is that the ordering and ranking happen on a partition by partition basis, which can be distributed and parallelized. Essentially, you're still sorting, but you're leveraging the database's or framework's ability to handle these operations in a distributed way. This makes it more scalable because each partition can be processed independently rather than needing to sort the entire dataset globally before applying the limit. So dense rank still involves ordering, but it does so in a more distributed and efficient manner for large datasets.
Why? I still don't know why. I thought shuffle still happen, and and essentially it's still slow.
I get what you're saying. Even though dense rank still involves ordering within partitions, the difference is in how the workload is managed. In a large distributed system, the dataset can be divided into smaller chunks partitions that can be processed in parallel. When you use dense rank, the ordering and ranking happen within each partition independently before the results are combined. This means that each partition can be processed on different nodes or machines simultaneously, making the operation more scalable and often faster for very large datasets. In contrast, a global order by over comma limit typically requires a full sort of the entire dataset, which can be slower and more resource intensive as the data grows, because it often has to be done in a more centralized way. So, the advantage of dense rank in a big data context is that it leverages the parallel processing capabilities of modern data platforms, which can make a huge difference in performance and scalability.
Okay. Thank you very much for the session. I think that's enough for today.
You're welcome. I'm glad it was helpful. Good luck with your interview and have a great rest of your day.
Yeah, thank you very much. Goodbye.